Hi, welcome to section 2.3, the slope and rate of change considered algebraically. It's a really simple section in as much as there's not a whole lot of content. I have no idea why they split it into 2 lessons again, but this should be a pretty straightforward section for you to grasp and then just do all the homework like that. All right, here we go. All right, we're going to start by remembering something that we learned in the last section 2.2. We learned that the derivative of a function at some point x is the slope of the line tangent to the function at that x value. We showed it graphically, so let's look back at that. In order to approximate the slope of the tangent line at a point x on our function, we're going to start out by using a secant line as an approximation. So this green line is our secant line, and a secant line is the line that goes through 2 points of a function. So here's the first point, x, comma f of x, and the second point, which is a little bit to the right, so in other words, it's x plus some value h along the x-axis, and the function value then of course would be f of x plus h. The slope of our secant line, just like the slope of any line, is delta y over delta x, which is rise over run. Remember, we're talking about f of x rather than y in this case. And specifically, our 2 points are x, f of x, and x plus h, f of x plus h. So here's our difference in y's in the numerator and our difference in x's in the denominator. And simplifying, we can say in that denominator that x plus h minus x is just h. So now we have this slope of our secant line, which is m is equal to f of x plus h minus f of x all over h. Now, to make our approximation of the slope of our tangent line, we're going to use that slope of our secant line, and slowly we can move that point x plus h, comma, f of x plus h, closer and closer to the x f of x point. And you can see that green secant line is getting closer and closer to a tangent line. And as that gets closer and closer to the tangent line, we can still calculate the slope of it. And eventually, once the point is right up next to it, we have the tangent line and consequently its slope. There's only one problem. Remember, we're pulling that point x plus h closer and closer to the point x. But as we do that, h gets closer and closer to the number 0. And remember that our slope equation has us dividing by h. We can't divide by 0. So what can we use? Oh, our old friend the limit. Look at that. Now we can describe that slope. As h gets closer and closer to 0, we can say what value that slope is approaching, and that gives us the slope of the tangent line at that point x. In other words, it gives us the derivative. Dun, dun, dun!